Hello, today we are going to study electricity chapter. So let's see first the introduction. So what is electricity? How many types do we have? What is insulator and conductor? So first let's see electricity. So what is electricity? Electric is the words derived from electro. Electro is nothing but study of charges. Okay. So in this electricity we have two types, static electricity and current electricity. So what is static electricity? Static electricity is nothing but study of charges at rest. Okay. So for example, so plastic scale attracts paper while it rubs on hair. Okay. So what happens when plastic scale rubbed on the hair? It will attract the paper, as we have played in kids. Okay, so it's known as, and current electricity is nothing but study of charges and motion. So next we have, let's study how do metals conduct electricity. So for any material to become good conductor of electricity, what should we have? They must possess a free charge carrier. So let's see what this is. What is this free charge carriers? Okay, so we have learned about the shells in 9th standard. So in your previous classes we have studied about the orbits, right? So what happens when there is an electron, that it will be revolving around the nucleons, right? So when there is a more orbit, the attraction between the nucleon and the orbit will be, last orbit will be lesser. So some charges will jump out. Those are known as free electrons. So free electrons are nothing but the electrons that cannot be controlled by the nucleons, okay, or that doesn't have any force towards the nucleons. So these free electrons, what do? They conduct electricity. Okay, so let's see now how does metal wire conduct electricity. So how does metal wire conduct electricity? So suppose we have a wire. Okay, so there are electrons which are flowing in between the atoms freely, but it doesn't flow constantly. So when there is no cell connected, so what happens when the cell is connected? So when the cell is connected, the electron starts to move uniformly or constantly. Okay, so that's how the metal wire going to conduct the electricity. Next we are going to study of conventional current. So the direction of convection current is nothing but our assumption where the current will be flowing from positive to negative, but actually the current will be flowing from negative to positive in practical cases. But according to our assumptions means according to our physical quantities that are associated in this chapter: electric charge, electric current, potential or voltage difference, resistance and resistivity, heat generated due to the current, electric power, Ohm's law, joules of heating and applications of heating. And these are the things we are studying in this chapter. Today we are going to explain about electric charge. So electric charge is nothing but a physical property of a matter experiencing a force when placed under magnetic field. It's of two types, positive and negative charge. So what happens for the like charges? Like charges repel each other. So if negative or positive come in contact, they're going to repel each other. They're not going to attract. But in the case of unlike charges, so what are they going to do? They are going to attract. So positive pole attract. Similarly, unlike charges are going to attract. Plus or minus or positive or negative charges, they are going to attract each other. So electrons carry a negative charge, that is nothing but minus 1.6 into 10 to the power minus 19 coulomb, and protons carry positive charge 1.6 into 10 to the power minus 19 coulomb. The smallest possible charge is nothing. It is the smallest possible charge, and the symbol we use for electric charge is Q, and the SI unit of electric charge is coulomb, and the electric charge is a scalar quantity. Next we are studying about electric current. So what is electric current? So I told you electro means charge, current is nothing but motion. So the flow of charges in motion. Okay, so they have given an example where for example, let's consider a water pipe where water flows from inside to the out. Okay, that's how the waters flow. So what we're going to see, this is nothing but water current. So we can consider the river. Okay, so the flow we're going to check by, oh, the water current is this much, so water current is high, water current is low. So the flow is nothing but Similarly, in the case of electric current, so what happens? The flow of charges, like how many charges have been flowed from here to here at the start and the beginning, is known as electric current. So at what time, like how many charges have been passed, so how many charges are flowing in a unit time or at a point certain time, right? That is known as electric current. So electric current is nothing but how many charges have been flowed in a unit time. So electric current is the rate of flow of electric charges. So electric charges is represented as q and the time is represented as t. So the rate of flow is nothing but the time. So how much charges have been flowed between this time. Okay, so the formula is nothing but I is equal to q by t. Is current, electric current, and the symbol is given by I. SI unit of electric current is nothing but ampere, and the symbol which we use for ampere is A. So for example, the current is 5 ampere, means we are going to write I is equal to 5A. Okay, so now let's define 1 ampere. So what is 1 ampere? 1 ampere is nothing but is defined as a transfer of 1 coulomb of charge per second through the, so 1 ampere is nothing but the transfer of 1 coulomb of charge in the circuit. Okay, but what time? Per second. Okay, so how are we going to represent? I is equal to 1 coulomb by 1 second, that is equal to 1 ampere. That's how we can 1 ampere. Very important. Next we are going to define 1 coulomb. So what is 1 coulomb? 1 coulomb is nothing but, so how are we going to get 1 coulomb? So we got the formula I is equal to c by per second, it's nothing but time, right? T. So if we want 1 coulomb of charge, how are we going to? 1 coulomb is nothing but I into t, right? So the t is going to be multiplied here. This is nothing but 1 coulomb. 1 coulomb is nothing but, so 1 coulomb is nothing but the current delivered through the circuit in 1 second, or in that time, usually it's 1 second itself. Okay, is known as 1 coulomb. So what is the device that is used for measuring electric current? It is nothing but ammeter. And how are we going to represent the circuit symbol? It is A plus and minus. Very important, ammeter is always connected in series with the devices. So what happens if the ammeter is connected in parallel? So why it has to be connected in series? So there is a reason behind it. So if the ammeter is connected in parallel, what happens? Ammeter will be shorting. Why? Because ammeter has a very low resistance, so the device will get burnt. Okay, therefore the electric current passing through that bulb or the circuit will be passed to the ammeter. Therefore ammeter takes all the power. Okay, that's the reason it will be shorted. And there is another device that is used to measure smaller current. It is nothing but galvanometer, and the circuit symbol for the galvanometer is represented as G. So you can see plus and minus. So why is galvanometer used? It is used because we can measure smaller current or sensitive current. It will also show the direction of current flowing through it. Ammeter just says the or measures the current, but it doesn't show the current flowing through it, but the galvanometer is going to show the current flowing through it. Okay guys, thank you.